Greetings and welcome, friends. Mr. Waddy here. We are on page 199. We were talking yesterday about scatter plots and lines of fit. Yes, what is the best fit line is kind of what we're talking about. Here I'm going to go through a couple of the homework problems. Hope you enjoy. And my students in real life are going to be here engaging with these problems and asking questions as they need to, giving me valuable feedback. It's going to be great. So here's the question. Use the scatter plot to fill in the missing coordinate of the ordered pair. So let's see. When the x-coordinate is 16, so here's my x-axis. Let's go. Moving along, moving along, moving along the x. Moving along. I found. Here's 16. There's 1 point there. What is that point's y-coordinate? Well, I would trace it across. 6. Right. Let's see. Let's find the point that has 3 for an x-coordinate. So moving along the x, going up the line, trying to draw it. Guys. Wait a minute. Did I? Oh, maybe I'm reading this wrong. 2. This is 4. Aha! So 3 is halfway between. Here we go. Moving up, moving up, moving up the line. Battleship. Right there. Hit it. And what's the y-coordinate for that point? Right, we just trace it across. 14. All right, let's work in the other direction. What if I know a y-coordinate is 12? So I go up to 12, 2, 4, 6, 8, 10, 12. Moving across, moving across, moving across the line. And then, yeah, trace this down. Looks like 7. I like it. And how about for 17? So here's 18, there's 16. Right, you just kind of trace it across and find its... Aha. So let's see, what's this, where does that hit? Yeah, it looks like 8, right? Very good. Cool. So that's not that bad, right? That's just reading points. Now here's some reading of points where we are associating them with particular values, like hard drive capacity, measured in gigabytes, and price. Yeah, that's what we're doing. Yeah. Question 7a. What is the price of a laptop with a hard drive capacity of 8 gigabytes? So I go over to 8 on the gigabyte axis, and there I go, and then I trace it across. Looks like that would be $1,100. Wow, wait a minute, what? It's the back 2 pages of that packet, I believe, maybe 3 pages. Wow, that's a bad price. Yeah, don't buy that laptop. This is this must be old data. But anyway, okay, here we go. What is the hard drive capacity of the $1,200 laptop? All right, here we go. So I go to 1,200, trace it across the line. And then I go down. How many gigabytes does that have? 12 GBs. Which a gigabyte is 1,024 megabytes, but sometimes people just kind of round that off to 1,000, it seems, which is weird, but that's what sometimes happens. All right, here's a question. What tends to happen? All right, tends, like what's the pattern, what's overall going on to the price as the hard drive capacity increases? So this is where we're starting to try to recognize what's happening in general for all of these points. And it looks like I could try to draw a line here, and it looks like that line, the price increases. Right? This was a positive slope. So price increases as hard drive capacity increases, right? As we go to the right with the x, the y values keep going up and up and up in general, okay? And now that wouldn't hit every point, but that's okay, right? I'm just looking for a trend, a tendency of those points. And theoretically, I could actually even find the number that it increases by. If I find some points that it hits, maybe these points kind of roughly. It looks like it's increasing by, it's time traveling again. What is the slope of my purple line between these points? This is going up 800 to 1,000. So the 200, 400, 600. And then, yeah, horizontally, what's this moving by? So this is 7, 8, 9, 10, 11, 12. 600 over 12 gigabytes. And if I simplify that, get the unit price, I get $50 per 1 gigabyte. All right. So you could, I think they were probably only just looking for it increases. It had a positive slope. But I just wanted to point out we could actually more specifically figure that out. And then if I was buying a laptop that was, say, I don't know, 100 gigabytes, right? What if I bought a laptop with 100 gigabytes? How could I figure out if that's a good price? Well, I would take the 100 gigabytes. It's $50 per 1 gigabyte, and I could take 100 and multiply by 50, and I would say, oh, I would predict it's around $5,000. I have a feeling that is still a terrible price for a laptop based on this data. $5,000 for a 100 gigabyte hard drive laptop. But I could use my line to predict a value like way out here. And when I'm predicting something that's out beyond the equation, this is called extrapolation. And if I was making a prediction like how much would a 5 gigabyte hard drive cost, right? If I wanted to like read off the line there, and I'd say, oh, that would be about $600. That, because it's between my data set, all right, like my data occurred here to here. And since this is between my data points, I'm making a prediction within the numbers that I had, within the range that I had. A prediction there would be called interpolation. All right, those are some words that might come in handy someday for you. Extrapolation is when you're predicting beyond what the range, or sorry, domain of your data originally was. Interpolation is when you're making a prediction within. All right, so that was more than they asked you, but sometimes you get more learning when you be trying. So it says, make a scatter plot of the data. Tell whether X and Y show positive, negative, or no correlation. So let me switch over to my here is page 199, question 13. I'm going to select the data, right? I'm going to go to insert chart. I'm going to say, like, give me a scatter plot. Show me that scatter plot. I say insert. Actually, maybe I should advanced edit. Let me just change and customize my points. I like my points to be 10 pixels in diameter. And fill out a pass. I'll sign it. No worries, friend. No worries. All right, let's see. Oh, how did I do that? All right, so here's my data. Right, you guys could have graphed using a variety of means. Yeah, just write name, date, time, destination, those sort of things. So you guys could have used a variety of means, right? You could have just made your own graph. But if you were to use the Google sheet that I gave you, that's just perfectly fine. Now, looking at this data, does it appear to have a positive, negative, or no correlation? Like if I tried to draw a line that represented this, no, I can't like these points are all over the place, right? Like I can't really find a line that represents them. One of the ways I described it yesterday is if you try to draw a football, your best fit line would be kind of like connecting the endpoints of the football. But notice like my points are like really far from my line. I feel like this isn't a good representation. So I'm going to say no correlation. No correlation. All right, these points are just all over the place. I don't think they have a relationship that would work here. Right? So no correlation would be the answer. All right, let's look at this last question. I'm pumped about this. Question 16. The table shows total earnings, Y, in dollars. Delicious. Dollars. Oh no, sorry. Of a food server who works X hours. Let's see. So Y is the number of hours they work. X is the earnings in... No. Y is the dollars. Here, let's label these. Why not, shall we? So here's their dollars. Here's their hours. Okay? It says write an equation that models the server's earnings as a function of the number of hours the server works. Okay, so let me go back to my spreadsheet. I'm going to select what problem did I do? 16. Here we are. So here's the data. Hours worked X, total earnings in Y. Let's select our data. I'll go to insert. Let's do the chart thing, chart type. Scatter plot. Give me that scatter plot. Customization. Let's make our points a little bit bigger. Let's see, what's the inverse of green? Green for money. Let's see, that's actually there. That one will do. Insert. Okay, so here's my graph, right? Where did my magnifier go? What? Why does it keep disappearing? That's weird. All right, so, purple is the opposite of that dark green that I selected. All right, here we go. Copy. And so here's my table. Here, I'll put that over there. So I want to find the equation of the best fit line. So let's draw a line that represents this data, okay? I really don't know where that's coming from. It's weird. I'm going to have to figure that out. So a line that represents this data, well, it looks like it's steeper in general than that. I'm thinking, yeah, that one's pretty good, maybe a little less. Now, so I'm trying to match like the general trend of the slope of this. If you want my football trick, that kind of works. I'm noticing that I can actually get a line that represents these points really well. And then like this one point is kind of like way off the line. That happens sometimes. That's called an outlier, when it just doesn't represent, like that one point is kind of like, what happened? I don't know, but that's unusual outcome compared to the rest of the data. So here we go. Here's my line. Let's find some points on the line. Now the points on the line will not necessarily, in this case I did happen to hit one of the data points, but notice I didn't hit any others. And that's okay. That happens. Sometimes you hit none of them. So let's see if I can predict the slope. I'll use this point. It looks like that was a direct hit. So this point was 2, what was that? Was that like 32 or something? Let me go up and look at the data. 2, 40. All right. So 2, 40. Well, we'll use that point. And in general, yesterday I was saying don't pick points that are like close to each other, because like the estimation for where that point is will be more drastic and then significantly change the rest of the line. Pick points that are a little further away. So I'm going to pick this point over here at 6. And 6 appears to have, let's see if I can figure out what Y value that is. Between 90 and 20, that's 30. So if I divide this into thirds, this would have been 100. This would have been 110. I don't know. What do you guys want to call that? You want to call that like 108? Maybe? 108? I think so. Right? And it's rough, right? It's not going to be exact. You and I will have different numbers, and that's okay. So let's find the slope of the line here. So I'm going to have my sloppy slope is going to be 108 minus 40 over 6 minus 2. See, I feel like that was a little bit weird there. So I'm going to have m equals 108 minus 40 will be, what, 68 divided by 6 minus 2 is 4. 68 divided by 4, 17. Oh, excellent. Oh, I'm pumped. I'm pumped. I can't believe I happened to pick numbers that worked out so pretty. I was expecting this to be a decimal. It probably kind of should be, and that's fine. So let's now find the equation of the line. So let's put this in point slope form. So y minus, I'll use my smaller numbers for this one, 40 equals 17 parentheses x minus 2. And let's do some distributing. Whoop, whoop, whoop. Actually, I've been using purple for distribution for quite a while here. I might as well be consistent. So y minus 40 equals 17x minus 34. And then we'll add 40 to both sides. You guys are getting so good at solving, I know. Y equals 17x plus 6 is my equation. Now they asked me a question. They said, B, interpret the slope in the y-intercept of the line of fit. So the slope of 17 means, this is 17 over 1. The y value was measured in dollars, their earnings, and the x was hours they worked. So the slope is their rate of pay. All right, which is $17 per 1 hour, right? Because that fraction is 17 to 1, so $17 per 1 hour, right? So that makes sense. And what about the y-intercept? Now I ended up getting a y-intercept of 6, which this one doesn't make sense in real life. The y-intercept 0, 6 means they earned $6 for 0 hours of work, which that doesn't, here my dollar signs kind of, there we go, $6 for 0 hours of work, but that's not usually how bosses pay you. Okay, but that's what that would mean. Now, do you guys remember this yesterday? We actually can train our computer. We can ask our computer to give us its version of this best fit line. So let's see how close our best fit line comes to their best fit line. So let's see, let's go back to this. I'm going to go to advanced edit, right? I think you guys were also able to find it here by clicking on this little triangle, advanced edit. And watch this, customization, scroll all the way down. And here it says trend line. And if I pull this box down, I actually can say linear, which means give me a line that represents this. Exponential, which would be like a crazy slide. And a polynomial can be like all sorts of ups and downs and loop-de-loops. Not loop-de-loops, I completely lied about that. But let's see, give me your best fit line. And by doing so, it's done that. I'm going to say label it with the equation. Let's get a darker color here. I don't know. There we go. And I'll make it a thicker line and 100% solid. There we go. There's our line. I'll hit update. And there is, my magnifier disappeared again. I really don't understand why that's happening. Peculiar. Oh, I need this. I need my, all the way over here. Yeah. Copy. All right, and let's compare. Look at this. I can actually even like, oh, wow. How did I pick the color of the line that was going to invert to the blue that wow, that's amazing. Right, so I could actually, oh, wow. I just thought of something cool, guys. This is going to be like, where's my scroll bar? There it is. All right. Do you think I lined this up right? Something like that. Watch this. This is going to be so sweet. I think if I open up my layer tool, layers, I can actually phase in and out. I didn't line it quite right. But their line is pretty close to mine if you could imagine those points lining up. All right, so we can actually see the way that worked out. That's pretty cool. Let's see. Let me. I'll just put their line down here for a second. What is the equation of their line? Do you guys see it? Or let me ask you. Okay. So here's the equation of their line. Y equals 18.214x plus 1.786. What is the slope of their line? Yeah, 18.214. And their y-intercept was different than mine as well. They got 1.786. So as far as that goes, all right, I had 17 for my slope and 6 for my y-intercept, right? We were pretty close. And so if you do this on a test, I'm expecting all of us to get different answers, but like we're close-ish is kind of what we're looking at. All right, well, thanks for watching, Internet friends. Have a great day. Bye-bye.